עדי, ZipRecruiter.
אמרתי שאתה יושב שם. תראה את הפרדף אצלי? כן.
ההרצאה תהיה באנגלית, מכיוון שאני כמה אנשים שרוצים לשמוע את זה באנגלית, ואנחנו נמשיך בסדר.
אפשר ברוסית?
כן.
אפשר להגיד בגרמנית, זה פשוט.
היי.
זה גבוה מספיק, אל תדאג.
You see?
כן, זה מתרחק. נראה לי זה HDMI. בעצם זה שבא נעים.
אוקיי, עוד ניסיון? בסדר?
פשוט תהיי מהצד השני. כן, כן, יש קליקר. אז תגיד לך. אני נראה להשראה.
Okay. You see logos of 4 really cool companies here. What do all of these companies have in common? These are all companies that connect. They provide a service that connects between consumers and products or content. All these companies provide recommendations based on user past activity on the site. When we enter these sites, we expect them to recommend new stuff to us that we may not have found ourselves. This type of user experience is so addictive that it spares us the effort of creating a search ourselves many times. What was the last time any of you created a search on Netflix? In fact, this type of user experience is so successful that Amazon transferred it from the virtual domain to the physical world, as you can see in this photo taken in a physical Amazon bookstore. Making recommendations is not a trivial task, even if you're an expert in the domain. But it becomes even more challenging when you encounter something you've never seen before. Like this suspicious-looking object. I have no idea what it is, and I wouldn't know who to recommend it to. And this is what we're going to talk about today, the cold start problem and our journey to solve it in our recommendation system. A cold start means how to make recommendations for something we haven't seen before and we have no historical information on. So, I'm Adi, I work here at ZipRecruiter. I've been working here over the past 2 years on our matching and recommendation algorithms. ZipRecruiter is a marketplace that connects jobs and job seekers. It's aimed mainly at the American market. And it has jobs varying from truck drivers to tech jobs to nursing jobs. The Israeli office was founded 3 years ago, and it's grown rapidly ever since. We're now about 50 engineers here, most of whom you can recognize by the t-shirts. And our main focus areas are improving the site's machine learning capabilities and managing the immense amounts of data that we have. And we do have a lot of data. We have millions of jobs, job seekers, and activities on the site. That means we have a challenge of making our algorithms fit all these different types of jobs, but it also means we have a lot of data to learn from. So I'm going to talk to you about a specific challenge that we worked on, which is how do we find recommendations for a new job that is posted on the site. This is a job that we have no historical information on. So the first direction we took was the one we thought would be the easiest one and quickest one to implement. We get this job. A job is posted on the site with a title as raw text, a description as longer raw text, and a location. So we learned how to extract the most significant characteristics of the job. That means skills, title, location, and more characteristics. Then we looked at the other side of the marketplace, the job seekers. We took everything we know about a job seeker. That means resumes, activities they made on the site, which means applies, clicks, searches. We took all this data and aggregated it and put it in the same structure and the same characteristics that we used to define the job. When all our data in both sides of the marketplace were defined in the same structured way, it was easy for us to query and score the quality of the match. This solution included turning unstructured data, which means the raw text of the job description, into structured data, extracting the skills and titles. So first we had to build skills taxonomies and title taxonomies. And then we had to learn to extract all these skills and titles out of all this raw text. I'm not going to go a lot into it now because we're going to talk about a different part of the algorithm. But this is challenging, mainly due to ambiguity issues that if they're not handled properly, we might offer a truck driver a job just because its job description contained the words network driver. So this algorithm went online and it worked, and we improved it over time. If the first version, we implemented it only for 2 industries, the healthcare industry and the business industry. So we added support for all the different industries we have on the site. Being a marketplace, we were able to get feedback from both the job seeker part and the employer part. So we used that to improve our algorithm. And we added some machine learning components, such as people who apply to these titles usually apply to those titles, and use them to better our matches. And we improved it. But analyzing our results revealed we had an issue. We were doing very well on certain types of jobs and not so well on other types. And we found that this solution is not scalable because user behavior, job seeker behavior, is not unified. And I'll explain by examples. This is Jake. He's a student, and he works as a bartender in the city where he lives. Jake won't be willing to commute 2-hour drive for his next bartending job, and he probably won't be willing to relocate to it as well. On the other hand, Jane here is a VP product in a successful company in New York. She will probably be willing to move to San Francisco for the right job. And if we decide to limit her choices by a geographical radius, we could cause her to lose her dream job in ZipRecruiter Santa Monica. Another example, when you want to hire a receptionist, your skill requirement may be more lenient than when choosing the nurse that will give you medical treatment. These were just 2 examples, but as I said before, we have a very large variety of jobs on our site, and if we try to create the rules that fit each type of job, we would never be able to do it. So we said, we have a problem, and maybe we should take a different direction. So we had this idea, let's try using AI. We'll just take all the data we have, feed it to the AI algorithm, and it will figure it out for itself, right? Magic. Well, not exactly magic. It takes some work to make it learn the right way. So let's see what our next step was. We said, okay, we have this new job. We said we have title, right, description, location. We can even extract stuff like skills from it, because we already learned to do that. But we have no historical information for it. So let's try to get similar jobs. For these jobs, we already have a history. And once we find them, we can take the job seekers who apply to them, and there's a big likelihood that they will be interested in our new job. So the thing here is, how do we decide 2 jobs are similar? We already know we don't want to make the rules ourselves, right? What we want is for 2 jobs to be similar only if the same job seekers will be interested in both. Let's see how we learned that. We used Google's word-to-vec algorithm. How many people here know it? Okay, good. So I'll just briefly go over the idea. We took the word-to-vec algorithm and applied it to our usage. We call it job-to-vec. So on a very high level, word-to-vec is trained on documents of words. And it creates embeddings, which are vector representations of words. Using these vectors, similar words have nearby vectors. And basically what happens is, 2 words are similar if they tend to appear in the same surrounding context. So how did we apply it to our jobs? In our world, a specific job seekers applies is a document. And one job that job seeker applied to is a word in the document. Okay? Here, we're not looking at the job content at all. We're only looking at job seeker applies. So, if these are our documents, each document is job seeker applies, what we end up with, running the same algorithm as word-to-vec, is vector representations of our jobs, where similar jobs are represented by nearby vectors.
Does the order of the jobs you put on the document influence?
Good question. No, we modify the algorithm a bit, so we won't consider the order of the jobs, because word-to-vec does consider the order.
Yeah, consider the context.
Yeah, it required a modification.
When you have a new job postings, and the first job, how did the first job seeker find it?
Excellent question. Getting to it in a second. So we drew the embeddings on tensor board. These are actually, each point represents a vector that represents a job. We looked at it, we were amazed. We saw that nearby vectors really do represent similar jobs. But as the guy here pointed out, we have a problem here, right? Our mission was to work on jobs that are new and we have no applies for, right? They didn't exist in the documents that we trained on, so we have no embedding for them. So the next step was, how do we take a new job and place it in the embedding space? So if this was our first step, which created embeddings for jobs we have a history for, we move on to the next step of the algorithm, which is a neural network that learns to get from the job features to the vector representation. We trained it on the jobs that did have apply data and for which we created embeddings in the first step. And after it was trained, we were able to feed it a new job and create an embedding for it. Once we have an embedding for the new job, we can get the similar jobs and then use their contacts. This solution went online, improved our performance, but again, we found a problem. Let's look at it. Now we're looking at the first step of the solution, okay? The one that only uses behavioral data. We're looking at jobs here. These jobs were posted on 2016. And there were people there searching for jobs that applied to them. Let's look at this specific job. Now, a year later, an almost identical job was posted. Around that time, other jobs were posted, and people looking for a job at 2017 applied to them. The people who searched for a job in 2016 were not, hopefully, the same people searching for a job on 2017. Since we're only looking at behavioral data, we have no idea of the job content here. What we get is two different embedding clusters, one for the jobs from 2016 and one for the jobs from 2017. Now we get to the second part of the algorithm that looks at the job content. We have the job features. Let's look at the first job from 2016. We're trying to teach the neural network to reach this vector. And then we get to the other job posted in 2017, and we try to teach the network to get to that vector over there. So what happens is eventually we end up with something in the middle, since the features were the same. It was almost the identical job. And the embedding that's somewhere in the middle cannot find any of the actual similar jobs. So we took this two-step algorithm where the first part used only behavioral data and the second part used the content data and combined them to one flow. We have several versions of networks that do this. This is an example of one. And it starts from the job features and tries to predict the contact who applied to the job. As a byproduct, which is, by the way, the same way Word2Vec gets the word embeddings, we take the layer that's close to the output, and that represents our job embedding. The solution went online and improved our results again. And now we're proud to say that 80% of employers who post a job on our site get a quality candidate on the same day. So we talked about the similar jobs algorithm. Now I want to show you how it fits inside the entire solution architecture. First of all, let's start from the data. We store all our job data and contact data on Elasticsearch. The job data, of course, includes the embeddings, the vector representations. When we get a new job, our service is called, and it goes through the neural network that we have developed with TensorFlow. After the job features run through the neural network, we get a vector representing the job. Once we have this vector, we query Elasticsearch for the most similar jobs. Finding similar jobs is calculated by cosine similarity. That's used to calculate similarity between two vectors. Elasticsearch doesn't have this capability built in, so we've developed our own plugin on top of Elasticsearch, and that performs the query for us. The plugin was released as an open source, and if you're interested to hear about it, talk to Shlomi. He'll arrange the org to talk about it. So once we query Elasticsearch for the similar job, we can take the job seekers who apply to it, score them, and find the best matches. So I showed you.
Do you go over all applicants in your repository?
We go over all jobs to find the most similar ones. Actually, there is a modification there to improve performance. We did clustering on the jobs first, and then we query the most similar ones out of the jobs near clusters. Then for the job seeker part, we only use the ones who applied to these jobs. So,
how much time it takes to screen all jobs? To calculate the distance, possible distance.
About 100 milliseconds. For millions of vectors.
How do you score candidates? That you said it's called.
that can be another talk.
You clicked a lot of.
Oh, thank you. I told you I'll be in. Any more questions before we continue?
Since you're only concerned with the applicant applying for a job, you didn't mention any concern about
Is he qualified for the job? Yeah, that's part of the contact scoring part, which we do after we filter out the candidates that might be applied to the job. It's not covered in the staff, but it is a consideration, that's right.
How much data did you have for creating the initial embeddings?
We have millions of applies. It's about, I can't even tell the number. It's around 10 million, I think.
Do you use the feedback from the user?
Do I what?
How do you use the feedback from the users?
In this algorithm, well, when scoring the contacts, you mean the users, the employers, and the job seekers?
The job seekers, maybe they didn't get the job that was what they were looking for, so I guess the embedding wasn't as good as it could have been.
Good question. I'll repeat the question. It was, how do we use the job seeker feedback? Currently, we use it for manual error checking. It is in the plans to put it into the algorithm, but currently we're just using it to check ourselves.
How can you check it manually? I mean, it's not. You have a team of people that this is everything.
Well, I wish I could say we get that much feedback. We do get a lot of it, but not everyone will click on feedback and tell you exactly what they think. And we don't go over all of them. We just try to, say what the major issues we have are. Okay, so I'll continue. We talked about some iterations of a small part of our algorithm, but in the past 2 years, we tested 150 different algorithms on the site. That means we also managed to fail quite a bit. But making so many tests and reruns meant that we had to invest some time to make our flow work properly and not waste too much time on stuff around the main thing that we're doing. So,
is it production test? In production or test?
In production, 150 in production.
Why not test against the
including A/B tests? We do that. That means that stuff that already improved our test on historical data, and then we uploaded them. I'll talk about it. So this is the cycle of any machine learning project. You have the developing part where you write your models, training part, testing, and error analysis. And then you continue to the next phase of deployment, of development. So for development, we made our own in-house framework on top of TensorFlow. That framework is used for feature extraction, pre-processing, and representation. And that means that every time we want to test a new feature and add a new one, we can do it very quickly and don't waste time on all the stuff around pre-processing it. The training phase, we created a workflow management tool that includes data retrieval, pre-processing, model training, and testing. And we can run it by running a task on Jenkins. Our testing framework simulates production environment, but using historical data. And when we change just a small part of the algorithm, we can use that to test how it affected the entire flow. And for error analysis, we created a web UI that helps us go over our errors and analyze them intuitively and quickly. These are examples of some of our debugging and error analysis pages. So, for takeaways, what I want you to walk away with and stuff I learned in this project. First thing is, learn from your users. The thing that created the biggest leap in our performance was when we realized we had to learn from the user behavior instead of trying to set the rules ourselves. And when we changed our algorithm to work like that, it was the biggest boost. Of course, the fact that we have a lot of data to learn from helped that. Which brings me to the second point, which is know your problem domain. Solutions that work for one product won't necessarily work for another. On our site, a job seeker can be active while he's searching for a job, and once he's hired, he can disappear for a few years until the next time he looks for a job. This is very different from sites like Netflix or Spotify, where user behavior has a more continuous nature. So an algorithm that works in one case won't necessarily work on the other, which was sort of the case of the timeline issue that I showed you earlier. And the next point is analyze real examples. It's kind of a tedious work, and we don't like to do it. But some of our biggest steps forward were found by going over real examples and finding out by looking at real people where our problems were. And the last one is, if someone is still troubled by it, that this weird instrument turns out to be an ancient meat tenderizer. Thanks.
Can you say more about the error analysis, like UI, and like how you guys went about building it, and get like any advice in general?
Okay, sure. The question was about our testing UI and how we built it. That sort of relates to our testing framework. As part of our testing framework, we wanted to simulate a real production scenario. That means looking at jobs that are new and were just posted, and using historical data that's stored in Elasticsearch. So what we did was hold out like a month of applications, of user activities on the site, and create an Elasticsearch with all the data before that. Then we run our algorithm on the jobs that are posted just when we stop building the index, and use the applies from the month after that to test how well we did by testing the recall and precision on the number of replies. So this is our testing framework, and then the UI pages we're using, maybe I can go back to them. Okay, so they run the same algorithm, but they add additional data that might help us. For example, we can run the algorithm for a specific job. We can see what contacts what job seekers we returned from our service. Then we can see what job seekers actually applied. We can click on them and see their information and what other jobs they applied to, and try to see what we might have found that could help us. We also took like the jobs that most of our applicants applied to, and that means that we should have found them as being similar to ours. That's an example.
It's sort of a follow-up regarding the testing framework on how you actually test the historical data. I mean, you only have the ground truth, but the recommendation that you historically gave. So now you hypothesize about different recommendations. How do you extrapolate on the user reaction?
Okay, good question. The question was, correct me if I misunderstood, is we're creating a bias in our historical tests because all the historical data already use our algorithm, and then we're testing our performance based on its results, right?
Not exactly. I meant that you only have the very partial ground truth, and you cannot test you can't test the new algorithm. I mean, you can't. It's sort of, you can't have an unbiased estimator. So then you.
Yeah. Okay, so that's a question that's raised a lot here. The answer to it is simply that we're not the only algorithm running in the company and helping people find jobs. There are other algorithms. There are also manual searches that people do on the site, and other ways for people to get to jobs. And so we're not measuring ourselves against ourselves, but against the entire world.
Are you experimenting with contextual bandits or something like that to push it forward?
Yeah. Sorry, the question was, are we experimenting with textual, right?
Contextual bandits. It's a family of algorithms for something better than A/B testing, which also relates to the last question raised here about. Well, anyway,
Okay, contextual vendor. Okay, so I don't know what it is. I'll be happy to hear about it.
Okay.
Do you use your algorithm to recruit people?
No, unfortunately not. Our site is not aimed at the Israeli market yet. So I think the American branch probably does.
Awesome. Thank you very much.
Thank you.